This question looks a little bit different than what we're used to, okay? But it's essentially asking us to do the exact same thing that we were doing before. So if we need to write an equation of the line that passes through the given point and is parallel to the given line, okay? So the given line is this one that goes through these 2 points, which are 1, 6 and 2, 2. How do you find the slope of that line? Gabby? The rise over the run. What's the rise here? Perfect. -4 and then +1. So my slope is just -4 over 1, or just -4, okay? If we want our line, because part A is asking, okay, write a parallel line to that one. What's going to be the slope of our other line? -4. Your slope is going to stay the same, okay? So we're just going to do -4. Should look like this. And our slope is -4, okay? Now, in order to write an equation, all we need is a point and a slope. Do we have a point and a slope? Sure do, so we can use point-slope form. So we're going to write y minus 3 equals our slope, which is -4, times x minus 4. You guys agree? Okay, the point that I used was the point over here, the one that it asked me to put the line through, and then the slope that I'm using is the same slope as the other line. What do I do next in this problem? Gabby?
Distribute the -4.
Booyah. Distribute the -4, so I get y minus 3 equals what? Very good, -4x plus 16. Now, Seth, this is not in slope-intercept form. What's the last thing? Add 3 to both sides. So you should have gotten y equals -4x plus 19 for the line that's parallel to this one. How many people got that for A? Good, okay? Now, let's check out B. B is asking, okay, now we need the line that's perpendicular. It needs to go through the same point, so everything else is going to be the same. What's going to change, guys? The slope, okay? Instead of my slope being -4, what's my slope going to be for the perpendicular line? Pedro? 1/4, okay? You change it from negative to positive, and then you flip it. So it's going to be 1/4, okay? So we're going to write y minus 3. It's the same point, equals, but now my slope changes to 1/4 x minus 4. And then we distribute again. We're going to get y minus 3 equals 1/4x minus 1. Add 3 to both sides. Add 3. You get y equals 1/4x plus 2. All right, questions on the first one? Mina?
Actually, the second, are we doing the second one now?
Yep. Mm-hmm.
Okay, I'll ask after.
Okay. All right, for the second one, okay? Now, this second one did not give you points, okay, specific points to use. So you should have just picked 2 points. I see that this is a point, 2, -1, and I see that 1, -4 is also a point. What's the slope to go from this point to the next point? Well, we rise, how many? 3, and we ran 1. So my slope should have been 3/1, or just 3. So in order for a line to be parallel and go through this point, it also needs a slope of 3/1. Or m equals 3. So for part A, we're doing parallel. Our slope is 3. Our point is 3, -2. So we've got y plus 2 equals 3 times x minus 3. We distribute the 3. We're going to get y plus 2 equals 3x minus 9. We subtract 2 from both sides. We're going to get y equals 3x minus 11. and our slopes are the same. Do you guys see that? Okay, my slope was 3 for both of those lines. For part B, my slope is no longer going to be parallel. My slope has to be perpendicular. How would I change the slope of 3 to be perpendicular? Jonathan? Negative 1/3. So my slope is now negative 1/3, and I just use that instead of that slope of 3. So we're going to get y plus 2 still equals 1/3, make sure it's a negative, times x minus 3. When you distribute the negative 1/3, you get y plus 2 equals negative 1/3 x. And then you just subtract 2 from both sides. Y equals negative 1/3 x minus 1. Plus 1. 4.4, when we drew that line of fit, did it go through all of the points exactly? No. Some points it didn't go through exactly, right? So some points it did not go through exactly, okay? And when it doesn't go through a point exactly, that's something that we call a residual, okay? Now, the reason that we use a residual is we can determine whether that line that we drew is a good line or a bad line for that set of points, okay? So if your residual ends up being super, super large, that means that you've got a lot of discrepancy between your line and the data points. In other words, it's not a good line of fit, okay? But if your residual is really small, that means that there's not much space between the line that you drew and the points that are on your graph. In other words, your graph, your model is actually really good, okay? So for the definition of the residual, please, please, please highlight that it's the difference of the y value of the data point and the corresponding y value found using the line of fit, okay? So in other words, we're just going to subtract the y value from our model and take that away from the y value of the data point. So if our data point lies above the line of fit, we're going to get what's called a positive residual. Look over on the graph on the right. Do you see how the data point was above the line of fit? That's a positive residual. If your data point's below the line of fit, guess what you have? A negative residual, okay? Now, the reason that we're using this residual stuff is because we can use the residuals to show how well a model fits a data set, okay? If the model is a good fit, highlight good fit, then the absolute values of the residuals are relatively small, okay? So we keep our residual nice and small. The difference between our data points and our actual line of fit, the line that we drew, if that's small, then we know that we drew a pretty good line. There's not much difference between the line and the data, okay? But if the model is not a good fit, then the residual points will form some type of pattern that suggests the data are not linear. So if our residual's like very large, either we drew the wrong line or the data cannot be mapped with just a straight line, okay? Then that suggests that there's no pattern that we can identify with just a straight line. Our model would need to be more complex, okay? And then wildly scattered residual points suggest that the data might not have any correlation, okay? So I want you to write a little note to yourself. Low residual means a good model, and a high residual means a bad model. Low residual means that it's a good model, and a high residual would mean that it's a bad model. Okay? Do the second slide. And let's go ahead and do our first problem. Okay, so in example 1, it says that the equation y equals negative 2x plus 20 models the data in the table shown, and it's asking us, is the model a good fit? Okay, so go ahead and outline the y equals negative 2x plus 20. Label that your model. So that's essentially our line of fit, okay? Do you guys remember when we would calculate our line of fit, we would get into slope-intercept form? Y equals mx plus b. Imagine we did this problem, and this is the equation that we got, okay? Y equals negative 2x plus 20. We're now going to compare this model to how well it does with the data that we were given, okay? So we're given all this data. This is our scatter plot. And then we approximated that data using this model, or this is our line of fit, okay? Now we're going to compare the two, okay? So we've got x, we've got y, we've got the y values from the model, and then we're going to calculate the residual, okay? So in this y section, okay, next to the x, I want you to just put in all the sales values from the table, okay? So we're going to start with 19, then go to 15, then 13, so on and so forth. So it's 19, 15, 13, 11, 10, 8, 7, and 5, okay? All I did was I grabbed the y values from my table and I copied them over. Now, the y values from the model are going to be different. How would I get the y values from the model for that third column in my chart? How would I get the y values from the model? Aurora? Very good. Just take all the x values, which are right here, and plug them in to your model, okay? So our model was y equals negative 2x plus 20, right? We're just going to plug in all of our x values. So x for the first one is 1. When x is 1 and we plug it in, we're going to get y equals negative 2 times 1 plus 20. Negative 2 times 1 is just negative 2 plus 20. So I'm going to get positive 18. So when x was 1, my model y value was 18.
I don't understand, like, why do we have to find out what it is if we just look at it and it's close to it?
Yeah, great question. So we have to find out what it is because we have to compare our model versus the actual data. Because if our model was way off from the actual data, it wouldn't be a good model, right? Because then it would just be like, why were we even doing this if our model points are way different from our data? So remember when you were drawing that line of fit? What if your line was like way off compared to the data? Then there's no point in drawing a line, right? So we're just checking to make sure that our model is good, okay? All right, so let's try x equals 2. Amina, what was your question?
For when you wrote out, did you write it out in what formula? Did you use y minus y1?
No, so I just took the x value, which was 1. Do you see how our model is y equals negative 2x plus 20?
Yeah.
And instead of x, I put in 1.
Oh, okay, you just plugged in the number.
I just plugged it in, yeah.
Oh,
Okay, so I'm going to get y equals negative 2 times 2 plus 20. What do I get here, guys?
You get 16.
16. It's going to be negative 4 plus 20, which is just 16. So in my next row, after 18, I'm going to put 16. Brady, what's up?
Can I go to the bathroom?
That's our model value, okay? Now looking at these, are these pretty close? Yeah, so I would say our model's doing pretty well so far. 19 was the original one from our scatter plot. We got 18. 15 was the original one. We got 16. So we're doing pretty good, right? Okay, let's try the next one. When x equals 3. When x is 3 from our scatter plot, what was our y value? 13, right? Let's check if we get something close to 13. So we're going to get y equals negative 2 times 3 plus 20. Negative 2 times 3 is going to give me negative 6 plus 20, which will give me 14.
This is like the F map.
Kind of, yeah. Okay. Is 14 close to 13? Yeah, so we're good so far. Okay. Let's check x equals 4. If x is equal to 4, what do I get, peeps? Yeah, 12. Brady, what's up?
Isn't it just a pattern down by 2?
Ah, there is a pattern. We're going down by 2 every time, okay? But let's keep going. So we got 12. That's close to 11, so we're still good. If x equals 5.
Wait, did it say something about a pattern?
Yeah, but we're looking, when we calculate the residual, we're going to double check for a pattern. If we see a pattern in the residual, it's not a good model, okay? So when x equals 5, we're going to get y equals 10. When x is 6, we're going to get y equals 8. When x equals 7, we're going to get y equals 6. And when x equals 8, we're going to get y equals 4. So let's just fill in the rest of our chart. We've got 10, 10, and then 8, 6, and 4. Now, remember, the residual, okay, is your y value minus your y value from the model, okay? So check it out. All we're going to do to calculate the residual is take this 19 and subtract 18 from it. So 19 minus 18, and I get 1. Next, we're going to take 15 and subtract 16. 15 minus 16 is negative 1. Next, we're going to take 13 and subtract 14. And we're going to get negative 1. And we keep going. 11 minus 12, negative 1. Look what happens when we were super awesome with our model and our y values matched. What's our residual when x is 5?
0.
It's 0, okay? Remember, we want our residual to be as small as possible because that means we nailed our model on the head. It means that our model matched our data perfectly. So it happens when x is 5 and when x is 6. Do you guys see that? Because it's 8 minus 8, which is 0. Then we do 7 minus 6, which gives me positive 1. And then we do 5 minus 4, which gives me 1. All right, now draw a nice box around your residual. We're done with our chart. But we have to determine whether this is a good model or not. Now, this one's pretty obvious. Every single residual was less than 1, right? It was between 1 and negative 1. So this is automatically, we know that this is a really good model, okay? We were only off by 1 every single time, okay? But in order to find out, some problems are going to be a little bit more complicated. I want you to draw a little arrow. And all you need to do is just add all the absolute values of the residual. Okay? So we're going to take the absolute value of each individual residual and add them all together. So let's start with the first one. The first one, the first residual is 1. What's the absolute value of 1? 1. Plus, what's the next residual down the line? Negative 1. What's the absolute value of negative 1? So add 1. What's the third one? Negative 1. Find the absolute value you get. 1 plus 1 plus 1. Do it again. Plus 1. Now, what was the fifth residual? 0. So we're not adding 1, we're adding 0 this time because the absolute value of 0 is 0. Do it again, you get 0. And what were our last two?
2 plus 1.
So plus 1 plus 1. Now, we had 8 points to begin with. How many residuals should I have? 8. Okay, count them out. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Make sure you count them out because sometimes like you're going to miss a point. Okay? And you don't want to miss a residual. So I had 8 points to begin with. I have 8 residuals. When we add them all together, what do I get? 6. Okay? Now, 6 doesn't really mean anything to us, right? We have to take this 6 and compare it to the y values. Okay? Now, our y values went all the way from 18 down to 4. Is 6 small compared to those y values? Yes. And if it is small, then it's a good model. So we would say that this is small residual. Therefore, this is a good model. Now, looking at my y values, what do you guys think would be a residual that wouldn't be a good model? What would be a number for the residual if we added them all together that wouldn't be a good model? Amina?
Pick any number.
Yeah.
97.
97 would be a terrible model. Okay? That would mean that we're off by accumulating 97 points we were off. Okay? That's terrible. Okay? 6 is really good. What would be another example of like a bad residual? 30. 30 would be a bad residual too. Okay? And then anything less than 6.
Tavares, Floraville, please report to student services. Tavares, Floraville, report to student services. Thank you.
So guys, anything less than 6 would be a better model than this one, right? So you can even compare models with each other. But anything bigger than 6 is a worse model than this one. Do you guys see that?
So would that be the cutoff point? So if we were on the test, it would be anything has to be below 6?
It'll be obvious. So you see how 6 is like really small compared to your y values? 6 is like the second to smallest y value.
What about
Then
4?
if it was 4, it would be a really good model still, okay? Now, if it was 20, do you see how that's bigger than all my y values? That would be a bad model, okay? So make sure that you're comparing your y values to your residual, okay? Brady, what's up? 47. Back to,
I was gonna ask if I can go to the bathroom and Brady gets back.
yes, okay? Second example. Now, this one's a little bit trickier because there's a decimal, okay? I'll walk you through the first 2, and then I want you guys to do the rest, okay? All right. So our model is now y equals 0.2x plus 38. Our table, okay, is now age versus salary. So let's just go ahead and start filling in our 4-column table, okay? X and Y we just got from the table, 35, 37, 41, 43, 45, 53, and 55. Okay? You guys see that I just copied those down from the X values in the table, right? The next column will be my Y values. Again, just copy them down. So 42, 44, 47, 50, 52, 51, 49, 45. Now, we have to use my model in order to find the third column, okay? So each of those X values, you're gonna plug into your model and see what your Y value is. Then you're gonna calculate the residual, okay? All right, so we're gonna say our model is Y equals 0.2 plus, or 0.2X plus 38. And now we're gonna plug in all of my X values. So let's start with X equals 35. So X equals 35. We plug that in, we're gonna get Y equals 0.2 times 35 plus 38. Now, the reason this one's a little bit tougher is because of these decimals. So over here on the left, it's 37, 35 times 0.2. The 5 times 2 is going to become 10. 2 times 3 is going to be 6. Add 1 to it, you get 7. And it's not 70, it's 7 because you have to move your decimal over because of the 0.2. So 0.2 times 35 is 7. So we're going to make this 7 plus 38.
How do you even get a smaller number when it's multiplication?
Because it's a number between 0 and 1. Okay? So we get 7 plus 38, which is 45. So my y value when x was 35 is 45. So my y value from the model is 45. What's my residual at this point? Not just 3, though. It's going to be 42 minus 45. So it's what, Nick? Negative 3, okay? I'm going to do 37, and then I want you guys in your groups to do the rest of them, okay? So let's check it out. 37. So we're going to say x equals 37. So y equals 0.2 times 37 plus 38. Off the top of my head, I do not know 0.2 times 37, so I'm going to move this over. 37 times 0.2. 2 times 7 gives me 14. Put the 4 down here, bring the 1 up here. 2 times 3 is 6, plus 1 gives me 7. Make sure you bring your decimal over. So we got 7.4. Okay, so this is going to be 7.4 plus 38, and this will give me 45.4. So my y value from the model is 45.4. And then to calculate my residual, I do the y value from the scatter plot minus the y value from my model. So 44 minus 45.4. And I should get negative 1.4. Mm-hmm.
If we would have a problem with this, would we ever be able to have a calculator of
Nope.
some sort?
When x was 41, did anyone get the y value from the model? No, it's not 0.8. It's 47.
Oh, there was
Wait, was it?
No, it's 46.
46.2, right? So then you do 47 minus 46.2. 47 minus 46.2. What did you guys get for your residual? That's 0.8. Agreed? Okay. What was the model value for the next one, for 43?
40.
Was it 46.8? 46.6? And then you did 50 minus 46.6, and you should have gotten 3.4? Hey. And then when it was 45, it should have been 47.0 on the dot. Then it was 52 minus 47, which would have given us, what, 5? Okay. And then 47, when x is 47, y value from the model should have been 48.4. Is that right, guys? And then it would have been 51 minus 48.4, which would have given us, what? What do we get there? I think it's like 6. is it
It was 48.
2.6? Was it 47.4?
Yeah.
Whoops, you guys are right. It's 47.4, and then that should have been 3.6, right?
Wait, so if you notice that there's a pattern on the test, can you just like go up by the pattern? Or just
What's the pattern?
4? I mean, 0.4.
Oh. Yeah, but the x values aren't increasing by all the same amount. Do you notice that? 3.6. And then the next one should have been
8.6.
48.6. And then this one would have been 49 minus 48.6, which would have been 0.4. And then the last one should have been 49 on the dot.
Yeah.
And then it was 45 minus 49, which would have given us -4. Okay, so we found all of our residuals. Amina, what's up?
Oh, I just put 47. Do we have to point or you
No.
2 points off of that?
Nope, you could just put 47 on the dot, okay? All right, so we found all of our residuals, so what we're gonna do next is take the absolute value of all of them and add them together. So we're gonna get 3 plus 1.4 plus 0.8 plus 3.4 plus 5 plus 3.6 plus 0.4 plus 4. Anything that was negative changed to a positive because it's the absolute value. Anything that was positive is just going to stay positive. Now, I'm going to add these together using 2 at a time. So 3 plus 1.4 is going to give me 4.4. 0.8 plus 3.4 is going to give me 4.2. 5 plus 3.6 is going to give me 8.6. And 0.4 plus 4 is going to give me 4.4. I miss anything? No, right? Yeah. Then 4.4 plus 4.2 is going to give me 8.6. And 8.6 plus 4.4 is going to give me 13. You add those two together and you should have gotten 21.6 for your residual. Did anyone get that? Nice. Okay. Now, compare that to your y values. Is that a high or a small residual? What would you say, Gabby? It's pretty small. So we're going to say if it's a small residual, would this be a good model or a bad model? It's a good model. Okay. Based on those y values, guys, what would be an example of a large residual that would show that it's a bad model? Gabby? 60 would be a bad. Okay, 1. 100 would be bad, okay? Anything over your y value. So like I would say anything 50 or above would be a bad model, okay? So 26 being our residual, that's actually a pretty good model, okay? Why is the red line a better approximation of the data? And we can tell that through residuals, okay? Are the points closer to the red line or to the blue line? The red line, okay? So the difference between each of these points and the red line is going to be small. Do you guys see that? The difference between each of these, the residual is going to be small. But the difference between all of them and the blue line is going to be pretty big, right? Like, look how big these lines are. The difference between those points and the blue line. So what we say is the red line has a lower residual. So therefore, it's the better model, right? And the blue line has a higher residual. And is therefore a worse model. Now, what we're going to be doing is we're going to be taking actual models and actual data, and we're going to be calculating the residual, adding them all together and figuring out, okay, is this a good model or is this a bad model, okay? And the only thing that we need to do in order to do that is set up a chart that has 4 different columns, okay? All right, so jump. The next thing that we're going to learn about is something called the correlation coefficient, okay? So go ahead, find that R in that paragraph and circle it. and then underline correlation coefficient. Your correlation coefficient is something called R, okay? Now, we've talked about positive correlations, we've talked about negative correlations, and we've talked about no correlation. Do you guys remember that? Where all the dots were either going up, all the dots were either going down, or the dots had no pattern, so they were all like scattered around, okay? Now, what R means is R is like, okay, how strong is that correlation, okay? So if there's no correlation at all, R is going to be 0, okay? If R is a very strong and positive correlation, R will be equal to 1. That's the strongest and the most positive you can get. If R is equal to -1, that is the strongest negative correlation. And anything in between would be like a weak negative or a weak positive, okay? So let's put 2 examples. I want you to draw arrows right here and right here. And let's label these weak negative and weak positive. Okay? So R is basically our ranking. How strong is our correlation? So if it's a weak negative correlation, it's going to lie somewhere between -1 and 0. I would assign a value, let's say that the weak negative is -0.3, okay? That's really close to 0, right? But it's not exactly 0. So there is a negative correlation, but it's super weak. A weak positive example would be R equals positive 0.3, okay? Where it's pretty weak, but it's still a positive correlation. Now, what we mean by a strong or a weak correlation is by how close are the dots to each other, okay? So go ahead and look at the 4 graphs down below. We've got a strong positive correlation, a strong negative correlation, a weak positive correlation, and a weak negative correlation. Look at the 2 positive correlations, the strong and the weak. How would you guys describe the strong positive correlation compared to the weak one? Brady?
The dots are more together.
Very good. Let's write dots are more together. What else? How else would you describe the positive, the strong one compared to the weak one? Brady?
It has more of like a direction.
Yeah, more of a direction. Gabby, what were you going to say?
I was gonna say that.
The same thing, okay? And I want you guys to think about this as compact. Doesn't it look nice and compact? Okay? It's nice and straight. It almost makes the line for you, right? Now, our R for this one, if it's strong and positive, what is the R going to be close to? 1, okay? So I would say for this graph, our R would approximately be 0.9, okay? Because all those dots, those are really close to the line, right? And now, finally, let's talk about our residual. Would this graph have a low or a high residual? Why?
Because it's positive.
It's positive, right? But remember, what is residual? It's how far each dot is from the line. If our red line, let's erase that other line that we drew earlier in the lesson. Oh, I can't erase it. So ignore this one. Are those dots very far from that line? They are?
No.
I don't think they are, okay? All these dots are really close to that line. So in other words, we're going to have a low residual, okay? And when you have a low residual, it's a very good model. Do you see how that line very accurately represents all the data points? Okay? This is a good model. It's a strong positive correlation because of its low residual. Now, Victor, let's take a look at the weak positive. Do you think if we draw a line through all the points is this going to be a high or a low residual? This is going to be a high residual, okay? Do you see how the points are much further away from the line now than they were before? This leads us to a high residual. And how would we describe the points compared to the strong one? Let's add some words in there. How would we describe those points versus the strong one? Gabby?
It has less of a direction.
Very good. Less of a direction. Brady?
Scattered.
Scattered. Perfect. It's leaning more towards no correlation, right? It's less of a direction, scattered. So if you were to say, okay, let's try to assign a value for R for this one. What would be a good value for R for this graph? For our correlation coefficient. What do you think, Abby? 0.3 is perfect, okay? Do you see how it's not very close to 1? Because if it was close to 1, it would be a strong positive correlation, right? It's close to 0, which means it's close to no correlation at all. But it's still positive, because do you see how it's positive? It's still trending upwards, okay? And then let's do the same thing for the strong negative. Let's assign correlation coefficients. What would be a good correlation coefficient for the strong negative graph? R equals what? Brady? 0.9?
Negative
Is negative 0.9. Very good, okay? Do you see how it changes value when it's a negative correlation? What do you guys think would be a good negative or a weak negative correlation coefficient for the last one? R equals what? Jonathan? Negative 0.3. Perfect. Okay. Now, if I asked you this question on the test, okay, I'm not looking for the perfect correlation coefficient, okay? But if it's weak, I want it somewhere between 0 and 0.5. If it's strong, I want it between 0.5 and 1, okay? All right. Questions on our correlation coefficient. Aya, what's up? Last but not least, guys, we're going to talk about something called correlation and causation, okay? So correlation is when something's increasing, the other thing is increasing or decreasing as well, right? It's how much do those two data sections, how much do they correlate with each other, okay? Causation is different, okay? Causation is when one variable causes a change in another variable, okay? So it produces either a strong negative or a strong positive correlation, okay? But correlation does not always mean causation, okay? So let's take a look down here at A, B, and C, okay? There are 3 examples. Would the time spent exercising, ask yourself, if we increased this, if you increase the time spent exercising, would the number of calories you burned increase or decrease? Increase. Okay? So the more time you spend exercising, the more calories you burn. So what kind of correlation is this? Nick? Positive. It's a positive correlation. Okay? But now it's also asking us, is it a causal relationship? That's not casual, guys, okay? Causal. Did one cause the other? Did exercising more cause you to burn more calories? Yes. So this is a causal relationship. We would put yes, it is a causal. Oops, I spelled that wrong. Relationship. Okay? Now, if you're still confused about causal relationships, wait for the next problem, okay? The next one. The number of banks and the population of the city. If the number of banks is high, okay, if that's high, do you think the population of your city is going to be high or low? Or not affected at all? Not affected? You sure? Does anyone think that they do have a relationship? Grace?
I think they do because the amount of banks, that means different locations for people to live.
Yeah. If you have, like, think of New York City, right? Are there a lot of people in New York City?
Yeah.
Do you think there's a lot of banks in New York City? Absolutely. Okay. Now, think of like a small town in South Dakota. Do you think a small town in South Dakota has a lot of banks there? Probably not. Okay. So I would say these are definitely have a positive correlation, right? Because if you have more people, you have more banks. Agreed? So there's a positive correlation. But guys, did the number of banks cause the population of the city to increase? No. This is not a causal relationship. Okay? So you saw how in the first one, if you spend more time on the treadmill, obviously you're going to burn more calories, right? That one's pretty obvious. But if you increase the number of banks, is the population of your city going to have to increase? No, okay? It doesn't cause the other one, okay? So it's still a positive correlation because more banks are in the cities that have the higher population, but it's not a causal relationship, okay? You have to know the difference. Now, let's take a look at C. If you spend more time playing video games, so if we increased this, what would happen to our GPA? Brady? It's going to go down.
No.
Positive or negative correlation? Negative correlation. Now, was this a causal or not a causal relationship? It's a causal. Why? Can someone explain it to me? Nick, what do you think?
Because the more time you spend on video games, the lower your grade is gonna go.
Very good. It caused the other one, right? The more time you spend playing video games, the lower your grade point average is going to go, okay? If you spend all day playing video games, unless they're like math or English video games, which I don't know if they actually exist.
Cool math games.
Coolmathgames.com, okay? You're going to get a really low school average, okay? Your grade point average is going to be really low. Now, that's not to say that there are outliers, right? There are some people that can spend all day playing video games and keep a 4.0 GPA, okay? But we're going to think generally for these types of questions, okay? Don't look too far into it. The amount of time spent playing video games, if you increase that, that will lower your GPA, okay? It's a negative correlation and a causal relationship, okay? All right. Are there any questions on this stuff?